Okay, what do we mean about implicit differentiation? For an example, if let's say you had y equals to, let me say 2x, you will agree with me that if we have to differentiate the function, I hope everything here is explicit, right? It's clear that on the left-hand side you have y, on the right-hand side you have what? You have the function in terms of x. So it's explicit that you're derivating the function y in terms of x. So where we know the derivative of y, it is what? Dy over dx. That is derivative of y. But derivative of 2x, it is what? It is 2. That is explicitly so in differentiation. But let's say, for an example, you have a function now. Let's say we have y, let me say x plus y equals 2. xy. Now, in the midst of your functions, the function are not explicitly just say arranged. You have x in the midst of y, you have x in the midst of y. So the rule allows you that you can differentiate the functions implicitly. So in one case, if let's say you have at least a product of two functions, you'll apply product rule, but we differentiate y implicitly so that we know that differentiation of y is dy over dx. So the derivative of x here, it will be equals to y. So you differentiate x in terms of x and derivate y in terms of x. So derivative of y we said is what? It's dy over dx. So that is derivative of y. When you look into the right hand side, you have a product of y and x there. So when you differentiate, we are going to apply product. Where in a case the product will say in the first term we derivate y or x to say and multiply by the second function y. We're going to say plus. We're using product rule. We are going now to multiply by x and derivate y in the second term. So derivative of y is this dy over dx in terms of x. We're derivating y in terms of x. So we say we have an implicit differentiation because the midst of y we have, in the midst of x we have y, it's mixed masala. Then, when you're done, you must make sure that you simplify your x. What I'm saying with x, you need to simplify and make dy over the x subject of the formula. Changing over, changing x. We're going to take this term to the other side, which consists of 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 dy over the x, or you can take this one to the other side. But because our minds are used to taking things to the left side, we switch things to the left side. So I'm going to say that dy over the x, take this to the other side. I'm factoring out dy over the x, I'll have 1. Here, if I take an x to the other side, it will be negative x dy over dx. But I take out dy over dx as a common factor. Same thing, I'll be taking this y 1 times y. It's y. Take 1 to the other side, it will be minus 1. So therefore, we can divide on both sides of the function dy over dx equals 2. We divide by 1 minus x. Factor, it's a factor now. That's why we're taking out dy over dx. So we'll have y minus 1 divided by 1 minus x. If you have done it vice versa, you'll see that maybe your function can have 1 minus y. In the denominator, you'll have x minus y. It doesn't matter how you have simplified. So that is implicit differentiation.